Hey everyone, this is Animesh, and this is our first episode of Chat with Devs. So today with me I have Gaurav, and today we'll be discussing like what is eBPF tracing and how the Keploy does it and why is it needed. So hi Gaurav,
Hi Animesh.
how are you?
Hi guys. I'm Gaurav Kumar, software engineer. Yeah,
Yeah. So how's the day going?
it's going good. Solved a
Gotcha.
bug.
That's a very happy feeling, isn't it? Okay, then let's get started. Gaurav, can you like I know like what is tracing, but I don't know why is it being used. So like, can you tell me like why is it used?
So basically, tracing is a method used to monitor and analyze system calls or like application behavior at runtime. So it usually involves collecting data about the system operations, such as function calls, system calls, like context switches, and more. So this data is very invaluable for performance analysis, for debugging, and also understanding the system, the entire system behavior, you can say.
Gotcha. And right now we know in the realm of Linux networking and OS, the BPF technology has emerged and is expanding at a very exponential rate, right? So
Yeah.
before we deep dive into like what is tracing using eBPF, let me give a brief example. We can compare eBPF to the JS language. If we are using JS to build our applications for the web or web applications, then we use eBPF to write our programs on the OS and the kernel levels,
Yeah.
right? So that's a like a brief summary or a comparison in which you can comprehend what is eBPF.
Yes.
Moving towards on the same side, as I mentioned, like how tracing has evolved over with the eBPF technology since it has come into a lot of play. What's your take on this?
So yeah, you are right here. Like EVPF can be used for tracing because, like as you said, it's a very powerful technology in the Linux
Hmm.
kernel that allows you for safe and efficient execution of custom code. Like you don't
Right,
even
right,
have to change the kernel source code
right.
or to add some kernel modules. So it has gained some popularity because it's very flexible in getting system trace. So you
Hmm.
can like developers can just write EPF programs that are loaded into the kernel, and these programs can be attached to various hooks points, such as system calls, network events, kernel function executions as well. And there is
Gotcha.
also event based execution. So when the specific event occurs, the EPF program is executed, so it can gather data about the system's status, process, or the filter, like filtering this data, and like we can just pass this data to the user space for further analysis. And
Gotcha.
also,
So
like this data
when
is very invaluable for performance analysis and monitoring system health.
Gotcha. So when you talk about like data collection and analysis, like what are some kind of datas that or a collections that we can expect to get from this eBPF tracing?
Okay, so we can get function arguments. Okay, we can get
Mhm.
which function is called how many times, and like which function is taking a lot of time. Like these metrics we can collect from eBPF.
Gotcha, that makes sense. So like at the later stage of point, we can figure out like due to which process or which function call if the system crash or is there any malicious code that has been interfering with our main application code. So coming to Keploy, how does Keploy enhances or is leveraging the EBP of tracing?
For that, like I have to share my screen.
Okay.
Let me share
Yeah.
my screen. Yeah, so as you can see, this API client is nothing but our user application. So EVPF, Keploy uses EVPF to put K probes like hooks, basically system called hooks to capture ingress traffic. So
Mm-hmm.
we're using EVPF on two sides. First, just to hook on the system calls, just to get ingress traffic of like request and responses, And
Mm-hmm.
also for external calls, like if there is an external dependency, let's say MongoDB, Postgres, RabbitMQ, etc. So Keploy, what Keploy does here is, so it uses another hook point where through which it can just redirect the traffic to a proxy. So the flow first goes to a proxy rather than just the destination. So we can just there we can also trace all those packets, and we just parse it and decode those packets and save it in a YAML file. And you can see like you can analyze those packets. Yeah, like
Gotcha.
on the network layer, Wireshark also does it, does the same, but it doesn't decode the complete packet. You can't structure it and see it in different structure, different object format, like the packet type, the query.
Uh, so,
Yeah.
like I was coming to my next question on that itself. If you have to compare tracing through Wireshark and tracing through Keploy, like what would be your choice and why?
Obviously, I would pick Keploy here because at Wireshark we get a bunch of packets, just like we how we get in TCP dump,
Mm-hmm.
TCP dump. But here in Keploy, those packets are decoded, and we are parsing those packets and saving it in a YAML file where and that YAML file is in readable format. You can obviously edit those and just play around just to check how your application is behaving.
Gotcha, gotcha. Um, that's all for today. Just a tip of like we are just gonna touch the tip of iceberg. Could you let our audience know like what are system calls and what is C group in terms of when we are talk about eBPF in general?
So uh, let me explain about it's a system call. Okay, so there is a file operation, like read write operation.
Mm-hmm.
So first it these operations are handled by the OS level, like near the OS level. If you are trying to read any content from the file, there is a system call involved in it. If you are trying to write in the file, there's also a system call involved in it. Read system call, write system call. There are several system calls here. To connect to a socket, we have connect system call. So these are the
Gotcha.
system calls Keploy is leveraging. And C group, C group controls. Basically, C group is nothing but a control group. We have different namespaces here. Okay,
Mm-hmm.
and like Keploy uses C group functions uh, just to modify the socket information,
Gotcha. Gotcha.
like the destination IP and port.
Gotcha. So just adding into it, like in a layman terms, we can call it like a collection of our processes, right?
Yeah.
Gotcha. So that's all. Thank you, Gaurav, for a quick chat over like tracing with eBPF. And thank you, everyone, for joining in. We'll have another session next week at the same time on some new trending technologies with eBPF. Thank you, everyone.